Hi everyone, let's begin correlation with the use of Gretl. And today we are going to understand analysis of the correlation, interpretation of the correlation. But before starting this, first we will understand what is correlation. So correlation basically in any statistical relationship, whether causal or not, between two random variables or bivariate data. So basically, we can say correlation may indicate any type of association. In statistics, it usually refers to the degree to which a pair of variables are linearly related. Like, for example, if we will talk about correlation between the height of parents and their offsprings, and the correlation between the price of good and the quantity of the consumers are willing to purchase, as it is depicted in the demand curve, right? That we are showing on the demand curve. But here it is the most important thing, types of correlation. Types of correlation, it is the whether this correlation is this the first type is positive and negative correlation. Positive correlation means when we are talking about uh, price and demand of complementary goods, that is known as positive correlation. Complementary good means bread and butter, ink and pan. When the one product, let's say car and petrol or car and diesel, right? If the, let's say, one commodity demand will increase, so another complementary good, because car cannot run without fuel, so another commodity demand will also increase. So this is known as positive correlation. But price and demand are substitute goods, means tea and coffee. Right. So there is the, suppose the one particular commodity price is increasing, but demand is decreasing. That is known as negative correlation. Next, we come to the linear and non-linear correlation. Linear correlation means change, like for example, change in income tends to bear a constant ratio to the amount of change in consumption. That is known as linear correlation. For example, one person's income will increase, so that is accordingly as much percentage of the income is increased. Accordingly, their consumption is also increased. So means there is a constant ratio to the amount of change in consumption also as per the income is increased. So that is known as linear correlation. But non-linear correlation means we are talking about, for example, everybody have seen bamboo plant. So bamboo plant lifespan versus yearly growth is non-linear correlation, because initially you are giving water and each and everything you are giving, and here it is, because first 5 years very slow growth, but after 5 years there is a very sharp growth. So this kind of relationship is known as non-linear. Or we can take another example of non-linear. Let's say production. You are producing some crop and you are giving lot of fertilizer, but still it is output is not same. Right. So then this is known as non-linear correlation. Simple, partial, and multiple correlation. When we'll come about simple correlation means the study between the two variables, means only bivariables. Partial correlation means relationship between two variables while other variables are constant. But multiple correlation means more than two variables simultaneously. For example, performance of the firm depends upon size and age of the firm. Right. Means the performance of the firm, it is my dependent variable, size and age of the firm is my independent variable. And if we will talk about size, we are measuring in terms of the how many employees are working in that firm, and age we are talking about how old that firm. So this is the simple, partial, and multiple correlation. So let's begin with the help of the Gretel. How we are going to analyze? First of all, we are going to file, then sample file we have to go to, and the first one, it is the data set we will open. And I just want to show you, here it is, let's say wages and gross capital. Is there any correlation? So let me select both these variables. I will right click and correlation matrix. A moment I said correlation matrix, so what I will do, I will simply copy, and it is asking me whether you want to copy as RTF MS Word file, plain text, or LaTeX file. So I need only plain text. I will press OK and I will paste in my Word document. So now you can see I will discuss these charts also. So first example, correlation analysis between wage and cap, right? Cap means capital. So this is my output, right? you can see here, you can cross check these outputs, and these outputs I could be able to see the same outputs, same output. These are the outputs. So let me, and you can paste it here because I had already pasted. Let me paste it here, right? So this is the again repetition. And what I will do, I'm just deleting this, and now we are going to interpret these outputs. So correlation analysis between wage and cap, correlation it is 0.007. Under the null hypothesis of no correlation, t-value it is, there's the 1029 and 0.235. With two-tailed p-value it is 0.8135. So correlation coefficient, now we can see this is the correlation, right? And now this value indicates an extremely weak positive correlation, practically no linear relationship between the wages and capital. And what could be the hypothesis? Now we can see null hypothesis. It is this one is the no correlation in the population. But here is the alternate hypothesis said there is a correlation. Test statistics t value 0.236 and degree of freedom is 1029. So here it is, we have that is already reflecting. I'm just highlighting, and I would highlight with the red color. So t value, degree of freedom is 1029 and value of t is 0.235. So this one is two-tailed p-value is 0.8135. So how we are going to interpret these results? Interpretation is the p-value is 0.8135. It's very high because significant p-value is 0.05, and that is the far above any typical significance threshold. So as a result, you fail to reject the null hypothesis. So we can say in between these two variables, there is no correlation. So there is, how we are going to write interpretation, conclusion, there is no statistical significant correlation between wage and capital. And this one is the, let me, right, capital. And here it is, the data does not provide evidence of any meaningful linear association between the capital and wages. Yes, of course, if both are your independent variables, there should be weak correlation. Otherwise, there will be issue of multicollinearity. So absolutely fine in this data set. Let me come to the another example. So I'm using now another file. Once again, I'm going to start. And file, let me open data. And I'm using this my regression file I had already used in my, so it's saying it's one dialog box is open. Opening a new data file will automatically close the current one. Any unsaved work will be lost. Proceed to open data file. Yes, I do not want to save this work, this data. So let me go ahead. And it said the imported data have been interpreted as a cross tabulation. So no. Simply I have to go there and I want to check correlation of in between size and age, right? So simply I will go there, correlation matrix. So now these are my results. Simply I would copy and paste, copy, and again it will ask. So it is already have taken this instruction. I want in plain text. I will copy this and I will paste here. So I had copied, right? This is the analysis between performance and size. Sorry. So once again, otherwise, that will show you. Let me take another, I will select performance and size. So correlation matrix. And now I would like to show you this copy and I will paste it here. Performance and size, right? Copy, yes, plain text, right? I will close this. And I had pasted here, performance and size. Now you can see correlation in between these two variables, 0.342, and under the null hypothesis, no correlation. T is 48 is your degree of freedom and 2.5 it is your p-value. And two-tailed p-value is 0.01. That means it is significant, right? It's less than 0.05. So that means we can say null hypothesis we are going to reject and alternate hypothesis we are going to accept. So, but let's cross-check. Correlation coefficient, that is the value. This indicates a moderate positive correlation. As size increases, performance tends to increase as well. So hypothesis test for the correlation. Now we can see null hypothesis, no correlation in the population, but alternate hypothesis, there is a correlation. So test statistics is saying 2.529. and degree of freedom is 48. Two-tailed p-value is 0.14. It's how we are going to conclude it. So interpretation is p-value is less than 0.05, indicating a statistical significance at the 5% level. Thus, you reject the null hypothesis. Very true. Conclusion, it is how we are going to write conclusion. There is a statistically significant evidence of a moderate positive correlation between performance and size. So larger size appears to be associated with the better performance in the sample. So I hope I have taken two examples. First example was there is no correlation, and second example, there is a correlation. And now how we are going to, I had taken these examples in this first example, you can see R 0.07, right? There is the positive 0.7 correlation, and this is the positive, and there is the negative, because you can see negative sign. That is why the slope is downward. This is the positive correlation. And in this example, R 0.3, so there is the 0.3% correlation. That is strong correlation towards the left side, 0.07. This is the weak correlation, 0.3. And in this value, third one is R equal to 0, and there is no correlation, right? Not at all. Means both these variables are not correlated. For example, I am giving you an example of, let's say we want to check students' placement. Right, what factors are influencing for the placement of the students? So let's say I have taken two variables. Placement depends upon how frequently you are having burgers and pizza, right? So there is both these factors are not correlated at all. Rather than you are asking placement depends upon your personality, your communication skills, your knowledge, right? Your marks. And all these things I'm asking, so there would be correlation. But when I am asking, placement depends upon how frequently you are having pizza and burgers. So there is no correlation. This is the example of R equal to 0. So that means this graph is reflecting there is no correlation. But in the middle one, there is a weak correlation, both positive and negative kind of, and positive and negative. 0.7 means there is a strong correlation. So I hope you understand by the term correlation how you are going to define as well as how you are going to interpret with the help of Gretl. I hope this video would be helpful. Stay tuned and keep watching.